Good morning to all. Welcome back to lot-based protocol. The last video we have seen about the what is a lot and what are the different types of lot. Today we are going to see about in detail about two-phase login protocols. So as a revision for the lot-based protocols, a lot is a mechanism to control concurrent access to a data item. So there are two types of lot. One lot is called as exclusive lot, another is called as a shared lot, where exclusive lot is mainly used for read and write operations, where shared lot is used only for read operation. As informed in the previous video, we can have multiple shared lot at the same time, but exclusive lot can be given only one for one transaction at a particular time. Okay. So lots are requested to the concurrency control manager. Transaction can proceed only after if the request is granted. So now we'll see in detail about the two-phase lot protocol. There are many protocols are there for login protocols, time-based protocol. Today we are going to see about the two-phase login protocol based on the lots. Okay. So the main need of the lot is it ensures the conflict serializable schedules. You know what is a conflict serializable schedule? A schedule can be serializable if it is a conflict equivalent. Okay. So we have a two phases of this two-phase login protocol. One is called as a growing phase, another is called as a shrinking phase. Okay. What do you mean by growing phase? Whenever you are going to execute a transaction, it requires multiple lots in order to execute the transaction in concurrent mode. In such a cases, you want to request the lots one by one. Okay, the multiple transaction may obtain the lots, and once the transaction is over, the transaction may not release the lots. Okay, so it is a growing pace, lot 1, 2, 3, 4, 5, 6, 11, like that. Shrinking pace is transaction may release the lots, the transaction may not obtain the lots. That is a shrinking phase. That means after some time of execution, you may not need the lot for concurrent execution, so you may not request the lots. Similar in the phase one, you may request many lots, and the transaction will be continuing, and you may not release the lots at all until all the transactions are over. Okay. So the protocol, whatever protocol we are going to do, there should be a serializability. Okay. So it can be proved that transaction can be serialized in order of the lot points. That is the point where a transaction is secured its final lot. Okay. Up to that, it is serialized. So before starting the transaction, execution of the transaction, make sure that a sufficient required lots are obtained. And also another case is once the transaction is over, once the data item has been processed, and if the transaction does not need the particular data item, the lots should be released. Okay, so in that case, we can avoid the deadlock or the starvation problem. Okay, so but still, two-phase login does not ensure freedom from deadlocks. Okay. So there is a possible that cascading rollback is possible under two-phase login. To avoid this, okay, we called as a modified protocol strict two-phase login protocol. So here the transaction must hold all the exclude lots until it commits or aborts. Okay. So that is obtaining every, whether you are using or not, you are going to hold the lot until you require or not, you are going to hold the lots until the complete the transaction and comes out of the process. Okay, that is called as a strict two-phase login. In order to have a more stricter login protocol, we go for rigorous two-phase login protocol, where both shared lot and exclusive lots are held till it is commit or abort. Okay, so in this protocol, the transaction can be serialized in order in which they commit. Okay. So once again, repeat, there are two types of login protocol. The first one is a simple one where does not have freedom from deadlocks. Definitely there will be a deadlock. So in order to avoid, we have two types of improved version of the two-phase login protocol. One is called as cascading rollback. Another one is called the rigorous two-phase login protocol. In cascading rollback, in a simple manner, it will not release the exclusive lot until it commits or aborts. The second one is rigorous two-phase law is still higher, still stricter than the first one. In the case, all the lots, including the shared lot and exclusive lot, will not be released until they commit. Okay. So this is the three types. We have three types of two-phase lot protocol. One is called as a simple two-phase login protocol. Second one is called as a cascading rollback protocol. Third one is a redress two-phase login protocol. Okay. So there can be conflict serial schedule that cannot be obtained if two-phase login is used. However, in the absence of extra information, it is possible for us, okay, to need of a conflict serial be in the following sense. Okay, so the transaction given, although if it is not following two-phase login, we can find a transaction TJ that uses two-phase login protocol. Okay, the schedule for TA TJ that is not conflict seriable, then it is possible to have a two-phase locking protocol. There are some locking conversions can be used. In the first phase, can acquire lock S on item, can acquire lock S on item, can convert lock S into lock S upgrade. Okay, so that is upgrade. Once you got the shared lock, that can be converted to a exclusive lock. In the second phase, can release a lock X, can release a lock X, can convert a lock S into a lock S, okay, downgrade. The first phase is upgrade, the second phase is a downgrade. Okay, this protocol ensures serializability, but still relies on a programmer to insert the various locking instructions. So today we are seeing about the lock as well as two-phase locking protocols as well as different types of two-phase locking protocols. Thank you.